Alright, let's dive into the fascinating world of magnetism. To get started, we first need to understand the fundamentals of magnetism, which includes the concept of magnetic fields and how they are created by the movement of charged particles. So, what is a magnetic field? Well, it's an invisible force field that surrounds magnets and magnetic materials. It's responsible for the attractive and repulsive forces between magnets, as well as the interaction between magnets and certain materials, like iron or steel. Now, you might be wondering how these magnetic fields are created. The answer lies in the movement of charged particles, specifically electrons. You see, electrons are tiny particles that orbit the nucleus of an atom. When these electrons move, they create a magnetic field. In most materials, the electrons move to random directions, which means their magnetic fields cancel each other out. However, in some materials, called ferromagnetic materials, the electrons align in a way that the magnetic fields add up, creating a stronger, more noticeable magnetic field. This is what gives magnets their unique properties. In a nutshell, magnetism is all about the movement of charged particles and the resulting magnetic fields. These fields are responsible for the attractive and repulsive forces we associate with magnets, as well as their interactions with certain materials. So, the next time you're playing with a magnet, remember that it's the movement of tiny charged particles that's making all the magic happen. Moving on to our next topic, let's discuss magnetic poles. You've probably heard of the north and south poles of a magnet, but what exactly are they, and how do they determine the direction of magnetic forces? Magnetic poles are the two ends of a magnet where the magnetic field is strongest. Each magnet has a north pole and a south pole. These poles are named in relation to Earth's magnetic poles, as a magnet's north pole will be attracted to Earth's magnetic north pole, which is actually a south magnetic pole. A bit confusing, I know. Now, how do these poles determine the direction of magnetic forces? Well, it all comes down to the interaction between the magnetic fields of two magnets. The rule you might have learned in school is that opposites attract and likes repel. This means that when the north pole of one magnet is near the south pole of another magnet, they are attracted to each other. Now, on the other hand, if you bring the north poles or south poles of two magnets close together, they'll repel each other. This push and pull between magnetic poles is what creates the forces of attraction and repulsion that we observe when playing with magnets. It's important to know that these forces depend on the alignment of the poles and the distance between the magnets. The closer the magnets are to each other, the stronger the force, and the further apart they are, the weaker the force. In summary, magnetic poles are the key to understanding the direction of magnetic forces. The interaction between the north and south poles of different magnets creates the forces of attraction and repulsion that make magnets so fascinating to explore. Now that we've covered the basics of magnetism and magnetic poles, let's delve into the phenomena of magnetic attraction and repulsion. These forces are what make magnets so interesting and useful in various applications. As we mentioned earlier, magnetic attraction occurs when the north pole of one magnet is brought close to the south pole of another magnet. This is because the magnetic field interacts in such a way that they pull the magnets together. Conversely, magnetic repulsion happens when, like, poles, either both north or both south, are brought close to each other. In this case, their magnetic fields push against each other, causing the magnets to repel. The strength of these forces depends on two key factors: the alignment of the magnetic poles and the distance between the magnets. First, let's talk about alignment. When the poles are perfectly aligned, the attractive or repulsive forces are at their strongest. However, if the poles are misaligned, or tilted, the forces will be weaker. Now, regarding distance, the forces of attraction and repulsion follow what's known as an inverse square law. This means that as the distance between the magnets increases, the strength of the force decreases exponentially. For example, if you double the distance between two magnets, the force between them will be reduced to a quarter of its original strength. In summary, magnetic attraction and repulsion are fascinating phenomena that result from the interaction of magnetic fields between magnets. The strength of these forces depends on the alignment of magnetic poles and the distance between the magnets. Understanding these principles can help us appreciate the many ways magnets are utilized in our daily lives and in various technologies. Alright, let's explore the different types of magnets and their unique properties. There are three main types of magnets: permanent magnets, electromagnets, and superconductors. Each type has its own distinct uses and properties, so let's dive in and learn more about them. First up, permanent magnets. These are the most common type of magnets that you'll encounter in everyday life. They are made from ferromagnetic materials like iron, nickel, or cobalt, and they maintain their magnetism without the need for an external power source. Some examples of permanent magnets include fridge magnets, magnetic clasps in jewelry, and the magnets found in speakers. Next, we have electromagnets. Unlike permanent magnets, electromagnets only exhibit magnetic properties when an electric current is applied. They consist of a coil of wire wrapped around a core, usually made of iron or another ferromagnetic material. When an electric current flows through the coil, it creates a magnetic field, turning the core into a temporary magnet. The strength of the magnetic field can be controlled by adjusting the current or the number of coils. Electromagnets have numerous applications, such as in electric motors, generators, and magnetic cranes used in scrapyards. Finally, we have superconductors. These are unique materials that can conduct electricity without resistance when cooled to extremely low temperatures. When a superconductor is placed in a magnetic field, it expels the field, creating a phenomenon called the Meissner effect. This causes the superconductor to levitate above a magnet, which is the principle behind magnetic levitation trains. Superconductors are also used in high-field magnets for applications like magnetic resonance imaging, MRI, machines, and particle accelerators. In summary, there are three main types of magnets: permanent magnets, electromagnets, and superconductors. Each has its own unique properties and uses, ranging from everyday items like fridge magnets to cutting-edge technologies like maglev trains and MRI machines. Understanding these different types of magnets is essential to appreciating the fascinating and diverse world of magnetism. Now that we've covered the basics of magnetism and the different types of magnets, let's examine some real-world applications of magnetism. You might be surprised to learn that magnetic principles are used in a wide range of technologies, from medical imaging to transportation systems. Let's discuss three notable examples: MRI machines, electric motors, and magnetic levitation transportation systems. First, let's look at MRI machines, which are used to create detailed images of the inside of the human body. MRI stands for magnetic resonance imaging, and as the name suggests, it relies on the principles of magnetism to work. An MRI machine contains a powerful superconducting magnet that generates a strong magnetic field. This field interacts with the hydrogen atoms in the body, causing them to emit radio waves, which are then detected and processed to create an image. This non-invasive imaging technique is invaluable for diagnosing a wide range of medical conditions. Next, we have electric motors, which were found in numerous everyday devices, from household appliances to electric vehicles. Electric motors work by converting electrical energy into mechanical energy using the principles of electromagnetism. They typically consist of a stationary part called the stator, which contains electromagnets, and a rotating part called the rotor, which contains permanent magnets. When an electric current is applied to the stator, it creates a magnetic field that interacts with the magnetic field of the rotor, causing it to spin and generate mechanical power. Lastly, let's discuss magnetic levitation transportation systems, also known as maglev trains. Levitation. These high-speed trains float above the tracks. Thanks to the repulsive force between superconducting magnets on the train and electromagnets on the tracks. This levitation eliminates friction between the train and the tracks, allowing maglev trains to reach impressive speeds while providing a smooth and quiet ride. Currently, maglev trains are in operation in countries like Japan, China, and Germany, and they are being considered for implementation in other regions as well. In conclusion, magnetism plays a crucial role in a wide variety of real-world applications, from medical imaging to transportation systems. Understanding the principles of magnetism and the different types of magnets helps us appreciate the many ways this fascinating force is harnessed to improve our lives and advance technology.